Welcome friends, remember on this channel I post advanced mathematical stuff. So let's take a look at this integral here. We have the integral from 0 to pi of x sine x over 1 plus cosine squared x. This is an exercise in using substitution the right way to evaluate the integral. So what we can do is we can begin by, for example, setting y equal to the following, pi minus x. Why would we do this? Because it turns out this particular substitution will give us an expression eventually that would be able to get back to this. You'll see. All right, so what we can do now is the following, of course, just transform the limits of integration. So when x has the value 0, the lower limit, right, then for y we will get pi. And then, let's see, when x has the upper limit value of pi, then for y we will get pi minus pi, which is 0. Those are our new limits with y as the variable. Okay, now I'd also differentiate this so that dy here, as you can see, is equal to just negative dx, which of course then tells us immediately that negative dy is equal to dx right here. Okay, so now let's rewrite the integral. So I here would be equal to the following. Now look, when x was the lower limit of 0, that became pi, right? So you put a pi here. Then when x was the upper limit of pi, that became a 0. Now let's transform the integrand a little bit here. Okay, so as you can see, also from here we can write that the following is true, like y minus pi is equal to negative x. So then you operate on this, it's going to give you that pi minus y is equal to x. Just multiply through by negative 1. So now you take this x here and you replace it with pi minus y. And then from there, the sine of x, what will that become? That's going to become here sine of, and then replace x again with pi minus y this way. Okay, and then the dx will become negative dy for now, so within parentheses. And then in the bottom, we're going to have 1 plus cosine squared, and now the new argument there is, again, pi minus y. So we're doing a variable substitution. Now take a look here, right? We have this negative, and then we have the limits from pi to 0. We can swap those pretty quickly. So I would be equal to the integral. That looks like the following. Now from 0 to pi back, and just get rid of the negative by multiplying by negative 1, I guess. So it's going to give us then the following integral. Pi minus y. And then for the part sine of pi minus y, we can do that with an identity that tells us the following. We're going to have here sine of pi. So in other words, what I'm doing is I'm taking this piece, right? I'm going to recreate that piece with an identity. Sine of pi, and then you're going to multiply that by cosine of y. And here it gets a bit long-winded. And then minus cosine of pi. And then at the very end here we have sine of y right here. And then dy this way. All right. Now, in the bottom, we can apply the same concept, really. So we're going to have 1 plus, and now we have cosine squared. So let's recreate that part as follows, okay? We're going to have, applying cosine of pi minus y, that identity. You're going to have cosine of pi, and then you're going to do here cosine of y, and then plus, and then sine of pi, and then sine of y this way. And then this whole thing would be squared at first. Here, friends, nice thing is what? Well, like for example, like this sine of pi, this will become a 0. That's good, right? This will stay, so this will vanish. Okay, let's see here. Sine of pi, this will be another 0 right here. We can get rid of those. So we can continue to simplify. You're going to have this integral that goes from 0 to pi. And let's simplify. So the first one is just pi minus y for now. You leave that. But then the rest of it, well, since this is 0, then this term vanishes, and then this becomes negative of cosine of pi, which is just, of course, negative here, 1 multiplying another negative 1, right, from here. So you're going to have, in other words, a positive sine y left over right here. Sine of y left over, a positive 1, and then dy. And then in the bottom, well, let's see what happens. Since this is 0, that means this whole term, of course, vanishes. And then here we have cosine of pi, which is negative 1 with the cosine y, but then you square it. So again, it just ends up being 1 plus cosine squared of y. Next stage in the process, we can just distribute this as follows. Take a look. Take this and just distribute it to the y, and then likewise distribute it over to the pi. So when you do that, we're going to have I is equal to this integral from 0 to pi, and distribute, so it's going to be pi, and then sine y minus y sine y, and this whole thing here is still hanging over that 1 plus cosine squared y dy. Now look very carefully. There's something happening here that's useful. You see, this is y sine y over 1 plus cosine y squared y, which is very similar to what we had originally, except for the letters being y instead of x. But the fact that this is y rather than x is just arbitrary. Those are just letters. So we can say instead that the next stage we're going to have the integral I and just rename the letters. So 0 to pi, because we want this, and we're getting close to it here. We're going to have pi sine x. So just replace y with x. They're just letters after all. And then split this into pieces. So it's going to be 1 plus cosine squared x. And then here is going to do minus the integral from 0 to pi. We need that, right? Because we're looking for this. We're going to have an I here. That's this. And then another I here. And then we can solve for I eventually. We'll see. So we have this. And then this part would be, again, just rename yx. So x sine x over that 1 plus cosine squared x dx. And of course, we know what this quantity is right here, right? To stress it, right? We know this is called I right here, right? We called it I at the very beginning after all. So that's good. So let's continue over here now. Okay, so that means that now what I have is I is equal to this integral from 0 to pi of pi sine x over 1 plus cosine squared x, and then minus I. What can we do next? Then we can just add I to both sides. So in other words, we're going to have naturally 2I like this is equal to the integral that goes from 0 to pi of pi sine x over 1 plus cosine squared x with the dx right here. All right, there we go. Now, just divide through by 2, so I would be equal to the integral, pull the pi out, so it's pi over 2, and the integral from 0 to pi of sine x over 1 plus cosine squared x dx, this way. We're getting close here. Now from here, just set u equal to cosine x, which means that du would be negative sine x dx. Also change the limits. So for example, when x has the value 0, according to this, for u, right, we would have cosine of 0, which is 1. And then when x has the value pi, for this, u would be equal to cosine of pi, which is negative 1. So with this, we can recreate now our integral basically as this integral of pi over 2. And it turned into a 1. And when x was pi, it turned into a negative 1 like that. And then let's see here. So sine x dx. Well, we're close here, but not quite, right? Because we have this negative right here. So we can just take that negative, move it over to the du. So that's going to give us the following then. Negative du over 1 plus u squared. We don't like to have a negative up here and a positive down below. So let's continue over here on this board. All right, we're going to have I is equal to pi over 2. And then let's see, flip these, but then that's going to get rid of the negative for us when you flip these limits, so they are a bit more natural from negative to positive. So you're going to have negative 1 to positive 1 of du over 1 plus u squared. Continue here, we're very close, correct? This can be done by using the inverse tangent function. So you have pi over 2, and then basically tan inverse, like this, evaluated at 1, minus tan inverse, that's what I'm writing right here, tan inverse, evaluated at negative 1, within brackets say. So I is equal to pi over 2. All right, we're close here. So this value here is pi over 4 minus Tangent inverse of -1 is a negative pi over 4. All right, we're getting close. So I is equal to pi over 2. And then let's see here. There's going to be a pi over 4 plus a pi over 4 within brackets or parentheses. I is then equal to pi over 2. So this is going to be 2 pi over 4. And of course, nicely what happens is, this cancels with this, which means, so friends, our final result is that I here is equal to, well, you got pi times pi, which is pi squared. And in the bottom, we have 4. So that's the definite, precise value of our integral. That is it for this one, friends. If you like mathematical content of this more advanced nature, please be sure to like and subscribe, and I will see you in another video.